Calcinus tibicen, Herbst, 1791, family Diogenidae. This abundant, widespread crab was the second most common species on Curaçao. It is a medium-small species, individuals averaging 8 to 10 millimeters in cephalothorax length. The left cheliped is markedly larger than the right. The chellae and ambulatories of the majority of specimens are dark red-brown with white tips. A second olive-green color phase was occasionally collected on Curaçao. However, matings were observed between the two types, so it is assumed that they represent only color phases of the same species. Calcinus tibicen was found in shallow, open waters almost everywhere around Curaçao. Although not present in enclosed bays away from open circulation, it was otherwise as widespread as Clibonarius tricolor. It was found in the same type of habitat as tricolor, although more plastic in its depth restrictions. In some areas, the crabs are in water less than 10 centimeters in depth. In other localities, they are common on rocks and coral fronds 3 meters deep. The diel variations in behavior observed in this field were not as marked as in Clibonarius tricolor. Likewise, this species did aggregate, but not as consistently as tricolor. When grouping occurred, the groups maintained during the day were small. In slightly deeper water, population often appeared to be distributed at random. However, in shallow water, groups of 15 to 35 individuals were common. Individuals of Calcinus tibicen were relatively quiet during the day. Just a few individuals could be seen moving about a little and picking at the detritus-covered rocks during the morning and early afternoon. Around 1630 to 1700 hours, movement and feeding activities started to increase. Between 1700 and 1800 hours, most of the individuals moved out of the restricted areas occupied during the day. This movement often appeared to be in several, if not all, directions for the members of any one group. Between 5:30 and 600 hours, the sky was light but the sun was not yet up. The crabs moved back into the areas of diurnal aggregation and became quiet, often withdrawing into their shells. One group of about 35 individuals, located directly in front of the Carmabi, in about 30 centimeters of water, were especially interesting in their diel movements. These crabs shared the interior of a submerged iron pipe with a medium-sized moray eel. The pipe was 10 centimeters in diameter and resting on a rock at one end, such that the middle of the pipe, where the majority of the crabs grouped, was 10 centimeters above the sand bottom. A large hole in the middle of the pipe permitted observation of most of the crabs. Some of these were removed until the moray eel interrupted, marked with waterproof ink, and replaced for further observations. Following initial losses, the number of marked individuals in the pipe during the day remained constant from August 18 to 26, when observations were discontinued. It was found that the crabs moved out in the evening by 1, crawling down the interior of the pipe to the bottom, 2, crawling on the pipe exterior to the bottom, or 3, up the pipe exterior to the rock the pipe was resting on and starting feeding activity there. However, in the early morning, all the crabs observed followed Route 1 back to the grouping area, crawling up the interior of the pipe after entering at the lower end. In this population, there was very little movement or feeding during the day, although 2 matings between a large red-brown male and 2 different olive-green females were seen. Field distribution measurements were taken as for Clibonarius tricolor. The results and the accompanying statistics are given in Table 4. It can be seen that the distributions measured are rather strongly contagious. The distribution of individuals in a uniform circular container in the laboratory was measured as in tricolor. The results are shown in Figure 16 for the two populations established. Accepting p equals 0.01 as the level of significance for the non-randomness of such distributions, it is evident that two of the diurnal and both of the nocturnal lab distributions measured were random. Even those counts which are statistically contagious are so only to a slight degree. Calcinus tibicen tends to group on or under large rocks during the day, and the non-randomness of the crab's distribution may be due to orientation toward some non-random physical factor of their environment, rather than the presence of conspecific individuals. Figure 16. Laboratory distributions of Calcinus tibicen. Histograms of number of individuals found in 32 equal segments of circular container. Table 4. Field distributions of Calcinus tibicen. A table we are not reading. Calcinus tibicen is an active crab, but its movements are slower than those of Clibinarius tricolor. Individuals of tibicen execute the ambulatory movements described for tricolor, and the patterns of movement are very similar. The full movement of the ambulatory is through about 60 degrees, bringing the limb to 10 degrees below the horizontal. Both of the chelipeds are employed in aggressive interactions. All possible variations, major cheliped, minor, or both, of the two types of cheliped movements do occur. The movements of the major cheliped are more common than those of the minor. Calcinus tibicen does execute a presentation as well as an extension movement. An extension is often carried out from the presentation position. The movement and posture of the limbs when executing a cheliped presentation are similar to those described for Clibinarius cubensis. The body is raised slightly as the cheliped is moved forward until the dactyl is perpendicular to the substrate. This posture is often maintained for a number of seconds. The cheliped extension is a slow but strong movement. In intense interactions, two individuals may mutually block the full movement of the chelipeds by repeated and sustained contact between chelipeds. This pushing is physically forceful, as evidenced by the speed and distance one individual may be thrown if it loses its footing. However, interactions of this type are not nearly as frequent as in Paguridae species. The dactyl of the cheliped is moved through 85 to 90 degrees to a position slightly below the horizontal. The movement from a neutral to a fully extended position takes 0.54 to 0.72 seconds. An extension from the presentation attitude may take only 0.48 seconds. The shell-fighting behavior of Calcinus tibicen is very similar to that of Clibinarius tricolor with respect to spatial relationships, positioning movements, and general execution of wrapping. The initial positioning movements prior to wrapping were not always extensive. However, positioning and rotating movements by the aggressor were more common before and between subsequent series of wraps. The aggressor moves approximately in a wide figure 8 over the aperture of the defending crab. The vertical portion of the movement is equal to 20 to 25 degrees arc. The downward wrapping motion was always completed in one frame of film, i.e. lasted 0.06 seconds or less. The complete wrapping cycles lasted 0.30 to 0.72 seconds, and unlike Clibinarius cubensis and vittatus, the shell was held in the fully raised position longer than in the fully lowered position. In an effort to elucidate several aspects of hermit crab social behavior, an attempt was made to provide some individuals with clear plastic shells of an appropriate size. The interior of the shells was an exact replica of the interior of natural shells, while a smooth hyperbolic cone was used for the external shape. These shells were made by Mr. R. J. Hazlett and the author. The only common species, which was large enough for the smallest shells available in quantity, was Calcinus tibicen. It was hoped that with these transparent shells, the relationship of the chelipeds of the two crabs could be observed when an attacking crab goes into the defender's shell and carries out wrapping motions. Fully realizing the limitations of single observations, this problem has at least a tentative answer. On one occasion, two Calcinus tibicen, both in plastic shells, were observed engaged in a shell fight. In this interaction, the aggressor fought for and won a shell of the same interior size and shape, but smaller external size and overall weight. After positioning movements and some wrapping with all ambulatories around the other's aperture, the large attacking crab went inside the shell aperture of the defending crab. While the attacking crab was outside, with major cheliped resting just inside the aperture, the defending crab's position had varied from one of complete withdrawal into its shell to a position rather far forward, with the major cheliped in contact with, but not interlocked or grasped by, that of the aggressor. As the aggressor moved headfirst into the other shell, the other crab retreated as far as possible to the inner whorls of the shell. Eventually, the cephalothorax of the aggressor was completely in the other shell. At the farthest intrusion of the attacker, the major chelipeds of the pair were not touching. The attacker then began wrapping, and as the motion gradually increased in intensity, the defending crab moved forward, occasionally making slight major cheliped contact with the attacker. The attacker backed out, continually wrapping, until he had backed out completely and the defending crab came completely out of his shell. At no time during this interaction were the chelipeds interlocked or used to pull at any portion of the defending crab. The sexual behavior of Calcinus tibicen resembles that of Clibinarius tricolor in general form. The male holds the female, which is always smaller, averaged 41% smaller in cephalothorax length, range 29 to 57%. In the opposed position, although some cheliped movements in the female aperture do occur, the precopulatory activity consists largely of rotating movements. There is not a clear differentiation into two types of intensities of rotating shaking as in tricolor. The male moves the female 60 to 75 degrees, around an axis perpendicular to and through the plane of the female aperture. Although tending somewhat toward the asynchronous figure 8 rotating of Clibinarius tricolor, the movement in Calcinus tibicen is more nearly circular. The speed of rotating is 0.36 to 0.72 seconds per cycle, average 0.48 seconds. Male Calcinus tibicen often grasp a female and begin rotating movements when she still has developing larvae on her pleopods. In one case, copulation took place and spermatophores were placed around the genital openings, while the female still had larvae attached. These were large larvae, 0.50 to 0.60 millimeters long, and possibly would have been released within a few hours. I have not observed the female molt during precopulatory activity, and do not know if the male assists the female in molting. On 2 occasions, it was possible to interrupt the precopulatory activity of a pair, place the female Calcinus tibicen in a clear plastic shell, and observe the subsequent mating activity. In one case, the female still had a full batch of developing eggs, and the male only intermittently held the female in the clear shell for the first 8 hours following her placement in the shell. During this time, the female released a number of larvae, but still had many on her pleopods when the pair was separated for the night. By morning, the female had released all her larvae, but there was no shed exoskeleton visible, so it is possible that she did not molt. However, she may have molted and the new exoskeleton hardened. When the pair was placed together, mating took place rapidly and copulation lasted about 8 seconds. During copulation, the distal segments of the 5th periopods of the male could be seen moving back and forth between the closely placed male and female genital openings. Later examination of the female revealed spermatophore material around the bases of the 3rd, 4th, and 5th periopods, and on the upper abdomen. With the aid of plastic shells, it was observed that, at least in the period just prior to copulation, a regular sequence of male-female interactions takes place. The male rocks the female. She moves up within her shell and touches the male's major cheliped, resting in her shell aperture, with her own. He taps the female with his major or minor cheliped, and she finally ducks back into her shell. After a number of these cycles, the last portions of the cycle are omitted. The female comes up further, tapping the male in the mouth-eye stalk region with her antennules and or minor cheliped. The male and then the female ease out of the copulatory position and copulation takes place. In most cases where the female was examined within several hours after copulation, she was soft, indicating a recent molt. The placement of new eggs on the pleopods does not follow copulation as closely as in Clibinarius tricolor. Of the 6 matings in which copulation was observed, only 1 was followed long enough after copulation to see some new eggs in place. In one of the female and plastic shell matings, a few new, 0.30 millimeters long, bright orange eggs were in place 10 hours after copulation. There is little or no post-copulatory behavior by the male. The female is pushed or thrown away almost immediately following copulation. As with Clibinarius tricolor, collections were made systematically throughout 1 month, and the egg diameters measured. The results are shown in Figure 17. Again, the data neither negates nor really strongly supports the idea of a lunar cycle in mating activity. The average size of the female's eggs did decrease and then rise to a higher level, as one might expect if the crabs mated, releasing the large old eggs, attaching the small new eggs, more frequently about the time of the full moon, July 6. However, the pattern is not smooth or consistent. The diel variation in activity was measured as in other species, and the results are shown in Figure 18. The decrease in feeding activity at night is not consistent with field observations, but otherwise the locomotor and feeding activity variation patterns appear to represent the same sort of patterns as were observed in the field. Figure 17. Variation in average egg diameter in Calcinus tibicen during May 1963. Figure 18. Diel variation in activities of Calcinus tibicen. Feeding activity shows evening peak. Aggressive activity crepuscular. Locomotor activity nocturnal.